So far we have seen what is Boyle's law and some of its practical manifestations in our everyday life. We have also explained it from the molecular point of view using the kinetic theory of gases. And now it is time to verify it in the lab. So we are going to use this simulation of its apparatus. It essentially consists of two glass tubes. One is closed at one end and the other is open at both the ends. These two glass tubes are then connected with a flexible rubber tube like this, forming a U-tube, and then the apparatus is filled with mercury, thereby trapping some amount of air in this part of the tube. Then the other end of this tube can be raised or lowered, thereby changing the pressure on the gas that is trapped here. And you can see as the pressure or the difference in this mercury column increases, the volume here reduces, and as the pressure is reduced, the volume would increase. Of course, we would need to establish the exact numerical relationship, and therefore we are going to give some exact numerical values to this mercury column here. So let us start by taking the value 5, and you would see this gas has expanded. So let us enter these values in this table. So here we'll be recording the difference in mercury column, delta H, and here we'll be recording the volume in terms of the length or height of this air column. So right now we have the values 5 and 18.77. Let's change this to say 10 centimeters now, and we have the second reading 10 and 17.67. Like that, we keep changing the height of that mercury column. So 15, then make it say 20. As you would see, the pressure is increasing, the volume is decreasing, but we haven't yet proved that they're exactly inversely proportional or something. For that, we need to consider one more factor. To understand that, let us take a look at this schematic of our apparatus. So this is our U-tube, this is a gas trapped, and we are going to look at 3 points in our mercury column, point A, B and C. B is at the top of this mercury column. So its pressure or pressure at B would be the pressure of the trapped gas. Point C is in the same thread of mercury and at the same level. So pressure at B and C will be equal. And what is the pressure at C? The pressure at C will be the pressure due to the mercury column on top of it, that is AC, and whatever might be the pressure on top of A. So what is on top of A? The atmosphere, because it is open to the atmosphere. And therefore the pressure at C will be equal to pressure due to mercury column AC plus the atmospheric pressure, which is 76 centimeters of mercury. So whatever readings we have got of this height difference, they need to be added 76 centimeters of mercury to get the actual pressure. So that's what we do next. We add 76 to all these values, delta H values, to get the actual pressure. And now we are ready for calculation. So this is the actual pressure in terms of mercury column. This is the volume in terms of this length, but we can still do the calculation in terms of length because all other things like density of mercury, gravitational acceleration, which will be taking part in pressure calculation, are constant. Similarly, the cross-sectional area of this tube, which would take part in the volume calculation, is also constant. So we simply need to now show the product of these two columns remains constant.